This is Advent of Code 2020, day 19. The problem is called Monster Messages. We've received communications from the elves at the Mythical Information Bureau, and they need some more help with their satellites. They've got an image of a sea monster, and it looks like they're having some problems. Essentially, what we need to do is take a list of rules for valid messages, and we need to sort of parse through that list of rules. And then after that list of rules, we're given a list of received messages, and we need to see which of those messages adhere to the message rules. So in this very simplified example, we have rule 0, which is says it needs to match 1 and then 2. So then we look at rule 1 and we see that that just matches an A. We look at rule 2 though, and that has additional rules that it must satisfy. So it needs to match 1 and 3, or it needs to match 3 and 1. So any order of, so for rule 2, we have either AB, 1 and 3, or we have BA. So the whole thing taken in aggregate reduces down to rule 0, where we say we either match A, AB, or A, BA, which we can see, they say right here. So those are the only two things that this very simplified thing will match. But we get to some more interesting examples like this one, where we just have several layers of nesting with our sort of base rules of 4 and 5 that trickle all the way up until we get to 0, which is a combination of a bunch of these different things. I'm not going to walk through all of it, but it looks like these are some of the valid things that match rule 0 for that particular example. So just to reiterate, a sample input that we might get is first a set of rules, then an empty line, and then a set of messages. And after parsing through those rules, we'd want to figure out which of these messages is valid and which isn't. So for this sample, we can see that these two do match, and the remaining ones do not. Yeah, I'm not going to go through the sample any more than that. That's just kind of the gist of it. I do want to take a peek, though, at the puzzle input, because I think that could, depending on how complex that gets, could affect how we want to approach first solving for the sample input. So I'll pop this open. And we start with 44 here. But the puzzle input said we're always going to be sort of reducing to 0, or we're always going to be using 0 as the rule that we ultimately match the received messages against. So scrolling back up, rule 0 is kind of what we have our eye on there, but it looks like these things are just coming in any old order. And then if I scroll down a little ways, yeah, it's looking like we've got, A here, we've got B here. Those are the only two characters we're dealing with, so that's a nice simplification. You can see that in the inputs as well. It's not like we're dealing with, A through Z or anything like that. And the other thing I'm noticing is that these pipes that represent sort of an either-or situation for the rules, none of these rules have more than one pipe. So most of these rules are going to have, two things or two other things. There are a few rules that don't have any pipes at all. So that's just kind of a flat rule of 97, then 54. And yeah, so I think as we start to work towards a solution, I think what we can keep in mind is we're only ever dealing with one pipe in a given rule. Stuff's coming in out of order. We are ultimately only ever reducing down to an A and a B, and all kinds of combinations of those things. So the way I'm thinking about solving this, and maybe it'd be helpful to jump back to here to talk about this, is that there's kind of two steps at a very high level as I'm thinking about it. The first step is, can we parse apart these rules and determine sort of some representation of a valid message. And then, given that representation of a valid message, can we check each of these received messages to see whether they're valid or not? So if we do the first part in a particular way, I think the second part will be pretty easy. And so the way I'm thinking about that is, if we can turn all of these rules into a single regex, then for each of these received messages, we can just check it against the regex. So I don't mean to trivialize the solution by saying it's easy, but rather I'm trying to, think that we can set ourselves up for success on the latter half of the puzzle by doing a bunch of legwork on the front half of it. Because what I'm imagining is, looking at this, we find, what are our base rules? 4 and 5. Okay, well then let's find all rules that have 4 and 5 and nothing else in them. Well, that's these two. So can we then substitute in A and B and A, and then AA and BB? Okay, well now we have 4 sets of kind of base rules that have been reduced to basically just the letters. So then, now that 2 and 3 is included, what else can we reduce? Well, we can reduce rule 1, because this is made up of 2 and 3 and 3 and 2. So then we kind of inject the reduced down rules of 2 and 3 into here. Well, now 1 is part of this set of base rules, and so we can build rule 0. And so I think if we are to build each of these pieces backwards till we get to rule 0 as valid regex strings, as valid regular expressions, then we should be able to run each of these messages against that regular expression and check whether we have a match or not. So with that sort of plan of attack in mind, let's jump over to the console. So I'm going to first create a sample.txt, and I'm going to paste in that bit of sample input there, save it, and then we will open up part1.ruby. And yeah, first thing first is to read in the file. So that'll be sample.txt. And I'd like to first split on the unparsed rules, and what do we want to call these? Rules input, received messages input. And that's just going to be an array, a 2-element array destructuring from file.split, where I look for a double new line. So that double new line is going to correspond to this line 7 right here. So then we'll split apart this top and this bottom, and that's what will go into these 2 variables respectively. So now I'd like to really jump back over here and grab this just to have something to look at. So I'll paste that as a comment, and I want to think about parsing this apart. So ultimately, I'd like to, split these each by line, but then I want to get to a thing where I have, I guess, a hash of like processed or flattened or reduced rules. Yeah, reduced. I like that. Reduced rules. It's going to get this. And so I'm imagining finding the A and the B and putting them right in reduced rules, where it contains the rule number as the key, and then the rule as the value. And so then you can imagine 5 pointing to B, and then I could see 3 pointing to some regex that would eventually look like AB or BA. I think I don't need to wrap these outer ones. I think like that maybe. Well, excuse me. So we'll play with this in the terminal or the REPL in a bit, but this is kind of the basic idea of what I'm going for. So reduced rules is a thing we will build up as we're sort of able to take these rules and reduce them down. And then the rest of these, until they get reduced, are going to go in, I guess, higher order rules. That sounds kind of computer science-y. Yeah, so we'll start there. So that'll be something like 0, 4, 1, 5, etc. Okay. So I would like to take rules input and split it on new lines. Okay. And then I'd like to map that over for each line. I'd like to say line.split, or actually even better, I'd like to say line.match, and we'll match on some digit. And I'd like to put that in a capture, followed by a colon and a space, and then the rest of this, which will be just any number of characters. And so that'll be the second part. And so we'll have an end of the line, a beginning of the line, and that'll be our regex. And if I call captures on that, that'll just return the array that's made up of this first part, the rule digit, and the second part, which is all this trailing stuff. So yeah, valid count is what we're ultimately looking for. So I'm going to put that out just to give the rest of the structure to our problem. And then I'm going to put a pry here just so I can see if the rules split is headed in the right direction. So we'll say rules gets rules. Yeah, and let's run part 1 and see how we're doing. Okay, no issues interpreting the file. What do rules look like? Yeah, 0 points to 415, 1 to that, 2, 4 points to, yeah. Okay, this is looking good. These pieces are a little bit weird since they have quotes nested inside of the string. So we'll have to, I guess, think how we want to handle that. I'm not sure yet. Maybe in this first pass, as we're parsing out the lines, we noticed in both the sample input and in the actual puzzle input that there's 2 rules we're kind of looking for as our base rules, the A and the B. So I wonder if we were to pull those out separately and then parse the rest of these like we've done here. That might be a cleaner approach. Have to think if there's a way to do that. Actually, yeah, so if I just want to jump back in here so I can puzzle that out. So rules, we have that. Get rules dot last dot last is the B, and is that going to match, like if I were to say B like this, is that going to match? Yeah, it does. So then if I were to capture that, yeah, I guess I just want to know what's the rule number that goes with A, what's the rule number that goes with B, and then I'd like to stick those into the reduced rules. So yeah, I guess given this list of rules dot, I guess find rule. So what's the rule where rule dot last dot match B? Undefined method match for, oh, because I called rules in there, I see. So as we iterate over each of these in the find, we'll get a single rule, which is a tuple. We grab the last part of it, we see if it matches, we get that. That's how we can find which one is B, we can find which one is A, and then the rest of them, yeah, the rest of them will go into the non-reduced rules. Okay. Copy that and hop out of here. Paste those in. That'll be B rule, A rule. And so, yeah, I guess we can say reduced rules gets initialized to B rule dot first gets B rule, or just, yeah, I guess in this case for these ones we're initializing, they just get the character, so B. Similarly, A rule, why do we call these rules? Just typoing all over the place. So the A rule first, that's the rule number. That is the key that gets assigned to A. So we've got both of those figured out. We then just want to iterate over the rest of the rules. And as long as we're going through those, as long as the rule number doesn't match the A or B rule number, we're going to stick it in higher order rules. Rules dot each do I don't know, ID in rule, something like that. I guess rule description thing, and we will say next if B rule dot first, A rule dot first dot include. So if that includes the ID, then we just skip to the next one. Otherwise, we will stick this rule into higher order rules. So we'll say ID gets rule description. And at this point, I want to pry again and see how we're doing. So we get here, reduced rules. That looks right. Higher order rules is 0, 1, 2, 3. Fantastic. This is looking good so far. So I think the task at hand now is to go through each in higher order rules, find any rule that is fully covered by reduced rules, turn it into a regex, put it in the reduced rules, remove from higher order rules. That's kind of the process I want to go through. Yeah, and we'll just, I guess, how do I want to say this? Keep going until higher order rules is empty. So once we empty out higher order rules, we presumably have a reduced rule of 0 pointing to a regular expression that we can then run all of our received messages against. So receive messages, I'll just pull this out now, is going to get receive messages input dot split on the new lines. And so this is what we'll process at the end. Actually, if I were just to sketch that out, I could say received messages dot count does the message dot match of reduced rules 0. Does that match? So this is either going to return nil or a or like a match object. So can not that to turn into a Boolean, and yeah, hopefully that'll count things up, and then that'll be our valid count. So each one that matches is a valid message, which contributes to the valid count, which is the answer we'll put out. Okay. So we've got this thing sort of bookended, and now we just have the hard part of building up this, what will be a massive regular expression. So yeah, I guess, just thinking about where to start here. And maybe I'll pull this down further so we can look at it. So knowing that our valid IDs are our reduced IDs right now are 4 and 5, which is something we can pull out of the keys of reduced rules. Yeah, reduced rules dot keys dot include. That's a little nicer. Yeah, so knowing 4 and 5, can we then basically get a summary of sort of the requirements for each of these? Like what if higher order rules was actually something like, 3 points to and sort of a hash like this where it's like I guess rule, right, where 4 or 5 or 5 4, and then we have dependencies, which I'll call deps, and that's an array like this that's made up of 4 and 5 and nothing else, because if we were to parse this apart, the only things that we have in here that we depend on are 4 and 5, so that would end up there. If we had this dependency array, that would allow us to sort of run through higher orders, identify any things that can be reduced. In this case, rule 3 could be reduced because all of its dependencies are accounted for in reduced rules. Rule 1 couldn't be reduced because its dependencies of 2 and 3 aren't accounted for, and same with rule 0. So we could just keep going like that, and that's this looping here until it's empty. And so on each loop, we'd update some reduced rules, we'd remove some things from higher order rules, and then keep going. So with that in mind, maybe we want to go a bit further here with this initial population of higher order rules. What if instead of that, we put in rule and then deps like we're describing down below? And so the deps would be, yeah, I guess, give me each of the each of the digits, a unique list of the digits in the rule. So yeah, if I were just to pry real quick, I'm curious what that could look like. So here's a rule. It's a rule dot match how do I say, like, give me an exhaustive list? Like, is that what scan is for? Like scan for like any number of digits like that. Oh, that is what scan is for. That was a little bit of a shot in the dark. Okay, and then you could say dot unique. Fantastic. Wow, sometimes Ruby just makes things as easy as they should be, I guess is a way of putting it. So the deps is going to be the rule description, and we scan over the digits and we take the unique ones. Okay. So yeah, I can imagine us wanting to start looping through now. So the loop could just be while higher order rules dot size is greater than 0. I guess we can put this in here so we can keep working on it. Find any rule that is fully covered by reduced rules. Okay, we can do that step. Yeah, I guess higher order rules dot filter. And we want to know is the higher order rule dot is the depths. Does that yeah, can we do some like set stuff here, like take that minus the reduced rules dot keys, and if that zeroes out, then we know that it's covered. So this minus this is, if that's empty, something like that perhaps. Then it would include it in the filtered ones. Yeah, what would that look like? Rules to reduce, I guess is what we could call this variable. Just indent that, and kind of curious to pry in at this point then. Gonna get rid of that one. And may actually just return after that so I don't get caught in there. No implicit conversion of symbol to integer. Okay, so what happened? That's line 44. Symbol to, that's interesting. Well, let me pry before this then, and we'll take a look at why that's happening, because it's not jumping out at me. So higher order rules dot first. Okay. Oh. I see. Okay, so this is returning a tuple, which is the key and the value, and that's what I tried to call that on. So what I actually want to do here is split apart and say key value, or ID and data, and then we can grab the depths off of it and do this comparison. So just to check, so that's last depths. Okay, and if we say minus 4, 1, yeah, 6, and then if we add 5, okay, dot empty, cool. So that's going to work. We just got to fix some of the destructuring that we got wrong here. So this will be ID and I guess higher order rule, that's fine. Or I don't know, rule data. Say rule data, grab the depths off of it, do the subtraction. Is it empty? Then put the whole thing in rules to reduce. That's interesting. So I'm turning a hash into an array of tuples, I guess. I think that's fine, just as long as I keep that in mind. So I'm just going to make a note of that here. It'll be something like 0, and then rule depths. Okay. So that's great. We figure out which rules we can reduce, and the next piece is to turn each of those into a regex. So this 3 is a great example. How do I turn that into a regex? I guess if I imagine that this is 3 coming in, and we have 4, 5, 5, 4, and then in here we have 4, 5. Yeah, how do we turn that into, I mean, I guess the target regular expression would be AB or BA, something like that. So if there's a pipe, we split on it, and then for each of those parts, we would do some appending of the subrules. So yeah, rule parts is going to get, I guess we're going to have to, rules to reduce, we're going to have to iterate over these. So each, and we'll say we get the ID and the rule data. So rule parts is going to be rule data, rule. All right, that's what we called it up here. Yeah, rule. So the rule data, we pull out the rule, we split on a space, a bar, and another space. I think even if that doesn't show up in one of our rules, you know, if we have a rule that looks like, you know, that's just like 5411, then I think we'll just get this in a single element array. Okay, so we'll take rule parts, and for each of the rule parts, maybe we can split that up even further. So rule data split dot map, and so this is going to be a rule part, I suppose, and we will split these by that, which I think we can actually just do a symbol to proc, because splitting on a space is the default for split. So we'll get rule parts will end up looking like, in the case of our number 3, will look like an array with 4, 5, and then it'll have a second array that's 5, 4. So then for each of these, we can fetch the piece of data from reduced rules, squash those together, fetch the rules from reduced data for this side, squash those together, and then combine it all with a parenthesis, a bar, and another parenthesis. Okay, so we'll say rule parts dot map. Yeah, map, and that'll give us oh man, I'm running out of names for what these sort of smaller and smaller pieces are. Rule parts, rule pieces. I'm going to regret that later. Rule pieces. And we will go through the rule pieces and say rule pieces dot map. Yeah, we'll map over it. And we'll say give us the reduced rules that matches the piece. And we just want to join those with an empty string. And that'll turn into a rule parts that looks like, in this case, AB, BA. So we'll follow that up with a join, yeah, I guess a join of on the pipe operator. Okay. Yeah, what do we want to call this? I guess the ready to wrap rule. How's that for a cool name? And the reason I say that is because I want the reduced rule to be basically the ready to wrap rule wrapped in parentheses. Open and close parens, and that, so we've got our reduced rule, and now we can I guess stick this rule into reduced rules. So this will take the ID and it will get reduced rule. Okay, and I think that's that whole thing. So turn into a regex, put in the reduced rules, remove from higher order rules. So rules to reduce. No, maybe we can just do that here. Remove it from and yeah, what's the, I'm gonna have to remember how you do that in Ruby. So if you have stuff in a hash, it's like A1, B2, C3. How do I say stuff dot remove A? Is that a thing? No. LS stuff. Reject. Hash methods. Select maybe. I mean, this is gonna, like, because it's got the bang on the end, it's gonna, you know, mutate the hash. So that's kind of why I think select might do it, but that also seems like sort of a backwards way of reject. I wonder about that. Reject. Nope. I could look this up, but I'm feeling a little bit stubborn about figuring out which of these it is. In shift, maybe? Okay, well. Oh, jeez. I was close when I said remove. How about delete? I say stuff dot delete A. It tells us what the value was of the thing it deleted and stuff. Yeah, okay, that will work. Stuff dot size, yeah, okay. What is the thing we're trying to remove from? Higher order rules. Delete at the ID. Keep going. That's already built into the loop. Okay. So that's just going to go and go and go until everything gets deleted. Until we build up our whole big reduced rules thing. And then we're going to come out this other end and be able to make a count. So, well, I don't know. If I kind of just want to give that a run and see if we've got an answer. So let's see. 3. I'm pretty pleased that that was able to run. So let's see. We match in the above example, A and B match, but this, and this do not match, producing the answer 2. Okay. So we're being too permissive, I guess. I'm wondering if it matters that, I wonder if we need to sort of have rule 0, so the kind of ultimate resulting rule, if that needs to be tied to like beginning a string, end a string stuff. So, yeah, what do we rule 0 gets how do you create a regex from I want to create a regex from dynamic input. Ruby create regex from string. Regular expression nil. Okay. String get. Oh, you can just do it like that. Okay, that's nice. So let's return to here. I want to say beginning of string, then reduced rules 0, and then the end of the string. And if we say rule 0 here, do we get 2 instead of 3? We do. Okay. That feels promising. So let's grab all of this input, jump back over here, put it in input.txt, 466 lines. Replace that there and give it a run on the big file. And we get 113. That sounds pretty good to me. Is that our answer though? Is that going to get us a gold star? It does. All right. Regex for the win 2 days in a row. That's another gold star, and we will see you in the next video for part 2. Thanks for watching.